UKMARSBOT. The subject of the talk is alternative control options for UKMARSBOT. And let's see what we have. Originally, when MarsBot was designed, we tried to make things as flexible as we could. And I thought that the most flexible option at that time was probably going to be the Arduino Nano. It was cheap, readily available, had more or less enough resources to do the job. And at the time that we looked, there were ST microcontroller boards which might be able to drop into the same slot. The controller had a lot of resources on it that were useful for us. So we could plug a battery straight into it. It had a 5-volt regulator so that you could just worry about a single power source. You didn't have to have any external regulation or anything like that. And you also, for testing purposes, could plug in the USB connection, get a serial port, talking to the device, and it would provide 5 volts, albeit at somewhat lower current. And everything was good. And when we looked at the Nano, it had an output of 3.3 volts. So that looked like a kind of flexible thing to bear in mind, the idea that we might want to support 3.3 volts at some point. So we slung it onto the sensor connector. And all seemed good. And indeed, it is good. It works and works quite nicely. So let's just consider the power supply arrangement for a moment. The voltage in is constrained to around about 7 to 12 volts, which is perfect for a couple of cells of lithium polymer. 3 cells is pushing your luck, it's a bit high. And the main reason why it's constrained into this range is because of the onboard regulator, which is a 1117 type. That's got a dropout of nearly 2 volts at low voltages, maybe 1.2, I think. And the upper limit is mostly about thermal considerations on the board. It can only give out maybe 250 milliamps continuously, and that's probably going to end up having it get pretty hot. So you don't want to do that. You don't want to be powering lots of stuff from that 5 volts continuously. The power is available both from that regulator and from the USB. And there's a little Schottky diode in there which does the steering to make sure that they don't kill each other if you have both the battery on and the USB power provided. There are some issues with it though. USB power is remarkably noisy. So if any of you are looking at one of these things and you want to test your sensors and you're going to do it only using the power available over the USB, be aware that the noise levels can be horrendous and you might think that your sensors are very poor when in fact they're actually quite adequate. Another thing to note is that regulators of this type have a body diode in the pass transistor, and if you apply 5 volts through USB, disconnect the battery and then put a meter on the V-in terminal, you will see probably about 4 volts going back through that regulator. A similar thing can happen through the motor driver. And I mention this because it's quite a surprise to people to discover that although they don't appear to have a power supply for the motors, there is power there, albeit not much, coming from the USB connector. And so your motors will turn, but you're starting to draw a lot of current and you can upset things. The existing 3-volt supply on the Nano looks quite inviting until you look into it a little more carefully. And then you discover that actually it comes from the built-in regulator on the FT232 serial to USB bridge on the original Nano. This is only designed to give a few tens of milliamps, maximum 50 milliamps, I think. If you buy a cheap clone board, then that same 3 volts comes from the reference voltage on the typically a CH340G serial bridge. Now that's only meant to be a reference, and in fact I couldn't find any specification for exactly how much power is supposed to be available from that. The long and short of it is that 3 volts, which looks so inviting on the Arduino Nano, is good for almost nothing. You might use it perhaps as a reference voltage for some analog application, but in terms of the robot and UKMARSBOT, it was not a good choice. It kind of tempted you into the feeling that you had some options for 3 volt, which didn't really exist. And so I would strongly suggest that you pretty much ignore it. By the way, if you go looking up the CH340, this link is for one of the better data sheets, because commonly you'll find a data sheet for the 340T or 340R, which are different devices. So another consideration when you have a look at any controller system is, where does the analog reference come from? And by default on the Arduino Nano, it comes from VCC, the processor supply voltage. You can change this in software. The ATmega processor has all kinds of options to use internal references, the AREF pin, and all sorts of things. But the default in all the Arduino software is to just use VCC. And I didn't check, but I believe that's just how it powers up. So the inviting AREF pin available on the Nano and the processor might tempt you to do clever stuff, or might make you believe that you need to use it if you change the system voltage. And in fact, you don't. So long as the processor supply is what you expect it to be, the default is that will be used as the analog reference, and all is good. The AREF pin, by the way, is an input, not an output. So if you go looking for a voltage on there for any purpose, you're wasting your time. So my advice, generally speaking, is to ignore AREF altogether. By the way, if you wanted to run your ATmega 328P Nano at 3 volts, you can, but not using the 16 megahertz crystal that's on there. You have to cut the frequency down to 8 megahertz. So all in all, the options here for using that 3 volts, or for changing the system voltage to 3 volts, become less and less inviting. And the reason for mentioning this is that, so much stuff now is 3 volts only. Well, before we finish with the original Nano, let's just have a look at some of the other constraints. If you've tried to do any programming using Arduinos on the basic 328 board, you'll find them quite constraining. It's relatively unusual for people to fill up the flash, but 2K of RAM doesn't go very far. Certainly, if you want to make a maze-solving Micromouse, you have to jump through some hoops in order to save memory to make that work well. And it's extra work, but particularly a beginner doesn't need to either do or understand, I feel. Also, the 328, it's quite old, but not obsolete. The analog to digital converter is pretty slow. I forget now, but it's, I think for 8-bit performance above about 45k samples per second, noise starts to become a problem. The timers aren't very flexible, so you can't just feed quadrature signals straight into the timer inputs and expect to get anything simple out of it, or useful out of it. That's why or one of the reasons why the quad XOR gate's on the board. And all in all, it's really only it's a 5 volt device. It's not very handy for use at 3.3 volts. So around about the time we were looking at designing the UKMARSBOT, there was the Nano Every became available. This is pretty much a drop-in replacement. It's a 5 volt device. It has a better voltage regulator, so it can handle a wider range of input voltages, which means that if you want to put three LiPo cells on to give the motors that extra boost, you can do it without fear of things going bad. The processor is still essentially the same AVR core, but running at 20 megahertz, so it's a little bit faster. It's got more flash. Most significantly for us, it's got a lot more RAM. 6K of RAM doesn't sound a lot, but it's enough that you can program common maze solving tasks, and you can make a smart wall follower without having to go to any extraordinary lengths to save memory. Just a bit of basic care is more than enough. Overall, though, it's just a replacement for the 328. A little bit quicker, more memory. The lack of EEPROM is a bit of a nuisance, but nothing damaging. And then once we were well underway, later in the year, Arduino started to release the newer Nano 33 boards. And these were really interesting because they had some serious resources on them. There's 3 boards, 2 of them are mostly the same thing. The Nano 33 IoT has a Wi-Fi module on it, which, by the way, is a full ESP32 processor tucked away inside there. There's also the Nano 33 BLE, which adds an IMU and the promise of Bluetooth, and the Nano 33 BLE Sense. The difference between those two is that the BLE Sense simply has everything populated on the board. Otherwise, they're identical. So you pay a little bit more for the BLE Sense, and you just get these extra sensors. You get color sensing and gesture sensing and temperature and humidity and a microphone, none of which are obviously very useful to the kinds of thing that we want to do, but you know, they're there if you need them, and you just plug in a different board and you get them. These boards are designed for 3.3 volt operation, and they have much better performance and much more in the way of resources. Because they're quite new, you can sometimes find it difficult to get full support for them. Some of the firmware in the radio devices seems not to be finalized or complete. And they have other uses for some of the pins, which is a little bit annoying. But if we have a look at what's going on board, you can see that the Nano 33 BLE uses the NRF 52840 processor. And thanks to Rob Probin, by the way, who saved me a lot of trouble and made a spreadsheet which I extracted from for this. The 33 BLEs run at 64 megahertz. They've got a megabyte of flash, 256K of RAM, no EEPROM, and they have Bluetooth and the IMU. The IoT uses a different processor for one reason or another, and its core is different. Notice that the BLE can run at 5 volts, but the IO voltage is 3.3 volts, and not all the pins are 5 volt compliant. So I would suggest not running it at 5 volts. It's really intended to use 3.3 volts. That, by the way, is what the 33 means in the name. So you don't get all the sensors on the IoT that you get on the BLE devices, but you do get the possibility of Wi-Fi if that is what you want. In terms of performance, those processors, and particularly the Cortex-M4 with a floating point unit, bring an awful lot to the game. And if you just cast your eye over this for a moment, it should be apparent that the 33 BLE with its Cortex-M4 is much, much faster. I mean, for a floating point addition, you're talking very nearly 100 times faster than the original Nano 328P. Square roots, 30 times faster. Trigonometric functions, 50 times faster. You're not going to run out of horsepower on these things at all. So if you really want to do some serious control work with lots of floating point calculations, these are the devices you want to be using. Just as an aside, because I noticed it when I was doing some control loop stuff on the UKMARSBOT. Just have a look down the Nano 328P column and see just how expensive a 16 or 32-bit integer divide is compared, for example, to the multiply. It takes 6 times longer to do a division, an integer division, than an integer multiply. And if you can, recast your software to not do divisions, even if they are in integers, because it turns out that even a floating point divide is faster than an integer divide on those devices. Discussion for another time. Oh, and don't do square roots. Square roots are going to kill you too. Right, so if we have a look at the Nano 33 devices and see what catches there might be to make up for these benefits. The Nano 33 IoT uses 4 of the analog pins for the radio. Right, so there's 4 sensor channels just gone. That alone means that I would say it's not a good match for UKMARSBOT. There's nothing you can do about it. They are internally wired and they will mess with your sensors. The BLE still uses 2 pins and they're used for I2C, for talking to the onboard peripherals. This is a nuisance. You still get 4 sensor channels, so you can still do a simple line follower or a simple maze robot. But if you want those extra sensor channels, you're going to have to think of something clever. You could, for example, put line follower marker sensors onto A4 and A5, run them digitally and try to make sure that they don't interfere with the I2C stuff, but that sounds like a bit of hard work. If you really want to do some work, you could have an external processor which just handles analog sensors and feeds results back over that same I2C bus, and so make yourself a sensor peripheral. But that's a lot of work. The Bluetooth is inviting, but I couldn't find any support for Bluetooth Classic, and BLE is just a nuisance. There are profiles for doing basic serial comms over BLE, but I haven't managed to find any that are easy to set up or easy to use. If anybody comes across them, do please tell me. So if we want to put one of these shiny new Nano 33 devices into the UKMARSBOT, what do we have to do? The Nano 33 boards are not fully 5-volt tolerant. So don't take any chances. Assume everything has to run at 3.3 volts. Fortunately, it looks to be very, very easy to modify UKMARSBOT to do this. There is a 3.3 volt power rail and a 5-volt power rail, and if you simply connect the two together, everything will work, more or less. And because the sensor connector has both these sat next to each other on a pin header, you could just use a little jumper across the two to join them together. There are some things which will want changing to be safe, and one of those is that the battery sense voltage divider needs changing so that you don't overdrive the analog input that measures the battery voltage. That's easily done by soldering a 4K7 resistor in parallel with the bottom leg of that. The drive to the emitter transistor may not be high enough depending on what transistor you've used. You may not get enough current through the emitters, but you're going to be adjusting the current limit resistors on those anyway. And the only thing which would actually possibly need unsoldering and replacing on the board is the exclusive OR gate, which is called out as a 74LS86 and really should have been called as 74HC86. The 74LS86 is not intended to work at 3 volts. It may do, it may not do, but it's not supposed to. So it would be safer to always put a 74HC86 in there, and then you can forget about the voltage. Finally then, because I've gone on quite a long time now, if you just want more memory and don't want to do any other changes, just swap a Nano Every in there. That will let you run all of the contests and just give you more resources. But if you want the extra performance, or if you want the radio, then drop in one of the Nano 33s, and I would suggest the Nano 33 BLE is your best bet. This gives extremely more, that's not a sentence, this gives a lot better performance. It's quite easy to integrate, only minor changes are needed. If you're building one from scratch, it's very straightforward to just make a couple of changes and away you go. Now, we originally were going to be talking about putting in the Nucleo 32 processors, but honestly, the Nano 33s have the same kind of performance. They're much, much easier to use, and I would commend them to the advanced builder. Oh, and all of these work with your normal Arduino software, although I would recommend using VS Code with Platform IO because it just handles a lot of this stuff a lot better. And there we are, done. Thank you very much.